Hello, everyone, and welcome to the broadcast. And I'm already derailed. Today we're going to try to finish up that shader logic for the flooring. Lots of math to do today. But before we get into that, let's see. We have Apple Juice and Skyline and Tyler showing up today. Welcome, everybody who popped in early or have just joined us. Checking in with the kitties, we do have Ember, Sammy, and Mason visible. Don't see any of the others. Skyline, I'm doing pretty well today. Let's put the camera on Ember. Oh, oops. Processing. There we go. Sometimes it be like that, Apple Juice. Sometimes it be like that. Ah, okay. I did not remember, but that explains some. Okay. So let me demonstrate where we are. I've turned off monster spawning, not bullet spawning yet. So this is if we don't scale it. We've already got some position wonkiness there. If I zoom out with Godot, we can see it. My camera. There we go. 0.1. We can see it's right about here, but it's not recalculating properly. So we have a couple things we need to accomplish here. We need to scale it, and this scale isn't really helping much. Scaling the actual thing. Because a lot of its parameters act differently. So this is about the right position for it being in 0, 0. But it's not supposed to be sitting at 0, 0. It's supposed to be sitting 1 block's width up and left. So if I times 6 this, because we're dealing with scale, which is not quite right, but they're all sweethearts. If you've been watching, you've met Molly then, right? Cat number 6. Okay, so this is about the right position for it. She is. She's a little troublemaker, and she's the first one that, outside of a tail, she lays right up next to the chair wheels, so I'm very paranoid now. She got some fur pinched a couple of days ago. Happily, it just frightened her. There was no harm, but now I'm trying to figure out a way to protect her from the wheels. over. We'll zoom out to make sure that we're doing this. Go a little further. We're walking, and it's gone. Completely gone. So some of this is because the block detection logic isn't right at the moment. So let's adjust some of that. We're going to remove 6, and we're going to put that as a constant. The constant shouldn't go here. There should be a master constant somewhere. But protected. Constant, integer. Well, thank you. I've heard people say that. I had never thought that I sounded soothing before, but I've been told it frequently enough that I have to assume there's something there. Width and a height. We're not going to use the baked-in scaling here, because I'm not sure how much this is affecting. So when we make the map, we make it 6 times bigger. This is generation logic to create an artificial map, that checkerboard that I've got going there. So the visible area size is we're adding extra blocks. This will create 3 in block pixel size. But we want the block pixel size also to be bigger. So we scale that up. So the tile size, we need to be cautious of. We're going to try adding scaling factors to all of these. We can't add scaling factors to these. These are finite numbers. These, I'm reaching into actual textures, so I don't want to mess with their scale. I'm expanding the size of the region. Update the shader visible area. So the visible area size is bigger. Then I want to add in what's that? So it's Steam open. We're going to add a uniform and scaling factor. So when we initially create material right here, I can set this value because it is an absolute. Love it when I accidentally press caps lock. Scaling factor is an integer, and it equals 6. Oh, no. This is still a string. Equals the name of the variable. So now we know what the scaling factor is inside the shader. So this is where things get a bit tricky. We still got to deal with positioning, but I want to get the scaling factor in here so that I know what we're dealing with. So I shouldn't be worried about the atlas. As much. Because this is coordinates. So I think already our atlas position is a little bit off. But we'll leave that as it is right now. All of this is figuring out what our tile is. We know our scaling factors, so there's a little bit of difference here. Let's also put it like that so we can see. I'm setting it to opaque black if it's not in the target zone. So we can see part of the problem already. Okay, so this is already way bigger than it should be. That looks way bigger than $90 blocks across. But that still may be okay. So up here we can see it's still painting it as if it were unscaled. Our visible area is increased. So we need to make sure that we're actually painting to where we expect to paint. So if we have a tile type that is greater than 0, we're going to reduce it by 1 because the empty tile is not specified in the atlas. It could be. We could leave 0 as an explicit blank in the tile so that we could control what a blank looks like. But I figure just leaving a blank as blank is just as good. So our ratio here is to make it so that when you're dealing with textures inside the shader, I remember why we have to do this, you are not dealing with pixel coordinates. You are dealing with a ratio. So it's not like if it's 10 by 10, then you're not dealing with, pixel 5. You're, pixel 5, 5. You're dealing with pixel 0.5, 0.5. So there's some weird wiggle that happens there. We want to be able to very clearly divide the space out so that we know exactly which spot to look at in it. But it creates some rounding oddities if we don't have the right size. Right now, I'm just going to ignore those rounding oddities, and we're going to try to pin it down. It's not going to render right in all positions. So this is us making sure it's got a valid tile in the tile atlas. We calculate how many columns and rows there are based on how big the texture atlas is and how big the tiles are supposed to be. The texture tiles. Right now, texture tile and tile size are the same. There is only one tile within the definition of the texture for a tile. We're leaving this to have a variation to it because we want to be able to, texture tile could contain multiple tiles so that we can programmatically create variation in the tiles with that setup. We'll see how that plays out. But again, for now, they're equal. So now we figured out that it is a valid row and column. Now we're saying, what's the offset? Which texture are we dealing with? Which part of the atlas are we dealing with? So effectively, we set up the X offset based on wrapping the row. So if there's 5 in the row, I have 0 through 4. We do a modulus on this so that, if we have, it's tile 6 and there's only 4 in a row, then we're actually going to get 0 through 3. Should be like 1. Index 1. We'd have 2 left over, so it's the second, so 0, 1. Then we're going to divide it out. So we get max columns. How many max columns are in there? This will always round it down because these are integers. We convert them into a float so that we can multiply by texture y. X and y are not guaranteed to be a square. They should be. They should be. There's no reason for them not to be. Same with tile. So I could just use this each time. Similarly, I could remove it from being an actual vector. But for now, we won't. So now we've figured out which texture tile we are. Now we're going to figure out which tile within it to use. Or at least which part of the tile to use. This is presupposition that there's only one tile in the texture tile. So we're trying to figure out which pixel. So we're figuring out what's the visible area size. So which position? Doesn't seem right. No, that should still work. We're figuring out which... This is us trying to figure out a pixel. But this is a little off already. Part of this is also going to be to make it scale. We have that scaling factor now. We need to use the same pixel 6 times as much. So instead of it being a 1-to-1, we are going to expand that out. So let's start up here where we decide what the actual pixel we're dealing with is. So map texture UV here. We're going to do UV. Can I do divided by 6 on a vector? Okay, we've got a little off there. You can see that it's drawing the individual tiles still at their scaled size. Itty bitty, that I should say. So this is part of it. We are saying when it comes to which map tile, we divide by 6. Can't be scaling factor here. We don't want this to be divided by 6. We want this to be divided by scaling factor. Let's make scaling factor a float. Hey there, driver. It's a heavy math day. So be prepared for that. Let's make scaling factor a float. Let's go in here and change it so that it is a float. Integer. Should be integer values, but because everything in the system works largely on floats and doubles, well, the cats are dodging. We're going to switch it over to vector 2. Sky is watching the curtain. So south of the bed, essentially, is a curtain. You can see where Sherbet is walking around in the play area. Sky is essentially facing that off of the bed. Does this create some uncertainty as far as floating point? Yes, but it shouldn't, because we're not really dealing with, like, division. The definition here. Oh, yeah. Needs to be a rectangle 2i, though, because we are dealing with pixels in we're dealing with pixel elements there. Positions can be fractional, except here. So these should not be. Tiles per block should also be an integer. Blocks per map should be a vector 2i, and tiles per block should be a vector 2i. This can be a floating point value, but it shouldn't. So we're going to change that over here. It should be an integer. And we'll just force it to be a float here so that it does the calculation correctly. Build, show me the errors. None. Okay. Unexpected. So again, now we have all of the subtiles, so we get that, can see that terrible flicker happening, largely because of refresh, but trust me, the artifact is kind of visible to me as well. The screen changed to squish a bit into the upper left corner, despite being the same ratio, creates more pixel artifacts. These should still be vector 2i's. Same with this. Hey there, Lore. We be mathin'. We be mathin'. So these still translate to a vector 2. They should. In theory, this might be an air surface. Might actually be an air surface. No, it would go crazy if that were the problem. If it were directly converting it in such a way that that would go wrong, we should be able to see it. Okay, so over in shader territory again. How you doing, Laura? So this is determining which tile. We're going to add the scaling factor in here. We're looking to change the ratio a bit. So we're adding the scaling factor into how much into the visible area we are. I think that made it worse. Is it not multiplied? Is it divided here? It's better, but it's still not the right size. So we can't mess with the tile offset. Because that will push us into different tiles if we do it wrong. We're using Atlas ratio to get the actual pixel out of that. So it's that we want to distort the impact of the tile offset on this. So what if we're gonna do a hard divide by 6 here. Again, made it worse. Because the texture tile offset should be putting us on the edge of the actual square to use. Then we're going to say, okay, which pixel is it actually? So in theory, you'd think it would be that. We're putting 6 here. That's what the scaling factor is. I just don't want to type out divided by scaling factor. Oh wow, that's unpleasant. Oh dear. So the thing is, this should be functional. This portion, which offset to use, is relatively functional. What I'm trying to figure out is where it's breaking down. We can't mess with this. This could distort it into different parts of the atlas entirely. It's that our position in the texture space isn't lining up properly with our position in the map. This will make it favor the upper left corner of the map tile. Like, it can't just be this. This will never reach 1 if we do that. So what I'm trying to accomplish here is that we know each pixel is expanded by the scaling factor that we want. If we make the tile area bigger, then now this should still work. Okay, visible area size in pixels we have. We should be able to map visible area size to map size. So how big the map texture is. We have map texture dot. No. Visible area size is pixel for pixel. Should still be proportional. So this is the UV of the visible area size. That proportion matches what's in the map texture. That should get us the color of that tile. If I've made the visible area 6 times bigger, I still get the correct proportion on the map tile. The map tile color. Map tile color that we'll be using. Which we then go down to here. This is still viable. It's got to be something with this. Again, we've tried that. We tried divide by 6 here, and that didn't do what we wanted it to. Divide by 6 would make it favor the upper left corner. Map tile are we in? Modulus tile size as an integer. Visible area position. Oh. But if we truncate visible area position, we could be losing parts of our value here. This is still the same thing. So this is our proportion of the visible area that we're in. If we say divided by tile size, let's do a we're trying to convert this over so that we get which tile it is that we're on. And we'll use that in the calculation instead of trying to do a truncation here. So we need to get this to be integer values. switch this. I position them this way because I like to have the variables declared in the order that I use them. As in, this variable is only relevant now because I've started to use it, as opposed to declare them all at the top whenever I think about them, you know? I thought of it last, so it's the last one. So visible area tile dot x is equal to, as an integer, divided by tile size x. Integer as a float. Little x. And we'll do the same thing, but with y. So what this is going to do is that this is going to get us times. This is going to truncate it. This is going to truncate. No, we can simplify that a lot. Okay, we divide this out, we round down. Then we multiply it back out. So then our tile offset is going to be this is visible area position x minus visible area tile x visible area tile y. Okay, this should truncate it all the way down to how many are in the tile offset. Now, I may have just done the same thing, but more verbosely here. May have just entirely broken it. That G shader. Still largely be the same thing. All right, quick break, then we're back to it. Let's reconsider how we're doing some of this math. Since we know... Your mind, Ember. All right. We know the size of things. And right now we have prior knowledge about this, so we're going to use that. So instead of using the UV directly, let's convert that over. I believe our tile size is 30 by 30. So this is where the scaling will come in, is that this is us finding which map tile to use. So if we do... B ratio. So if we do 1 divided by this, then we're going to get the amount of UV per tile. We're going to remove the tile here. Because when we're dealing with map tile, we're not dealing with pixels yet. So what would that be? Quick math. Ew. That's an ugly number. It's a repeating number is the problem. We need to dodge repeating numbers. Scaling factor of 6 is going to make that happen every time, though. And if we round it up, we're going to get distortion. But let's round it up. Repeat. Yes, thank you, Ember. No, again. This will make it gravitate towards the upper left. Can't have it gravitate here. We still need to stretch it out across the entirety. Effectively, we need to make map texture bigger. That's what we need to do to scale this. Map texture needs to be bigger. And changing the UV doesn't do that. It shouldn't need to be bigger. We shouldn't have to do any extra math here, because the UV is still going to be the proportion on the map. It's that we get rounding errors is the problem. So we need the UV to be in chunks that are map tile sized is what we're looking for. Do a quick look up here. Lorenzo, we're coding a game. Right now in particular, we're trying to code the floor of the game as if it's a shader. Oh, as a shader. We're dealing with math oddities here. Force the zoom out. Well, now it's not rendering at all. That's a problem. Oh, no, there it is. Performance is one of our primary considerations for the game at the moment. So right now you can see we have about upper left corner near the ear there. It's truncated, but we're sitting at upwards of 1200 frames a second with 21 objects. Let's make more things. We're going to be producing 3 to the 5th yarn balls every half second in a moment here. So 3,000 objects. At about 4,000, we start to lose frames per second steadily. If we go much higher, it's going to start dipping towards 30. If we make them move around, this makes their motion more complicated. It increases the amount of calculation we're doing. It gets lower. So we want to maximize the number of things on screen because we're trying to do Vampire Survivors, but a little more ridiculous. All of these are rendered on a shader as well. These are all rendered as a single mesh surface, and all of the collision is handled as a compute shader. The GPU is doing work. We went this way. We started with pure Godot. Godot 4.3, pure GD script kind of solution. We shifted from using the Godot objects, full sprites, collision, all of that in Godot, over to interacting with the rendering server and the physics server directly. And that still didn't get us the performance we wanted. We could hit like maybe 1,000 objects. This is not a fully realistic case. If we pull it down to here, a given weapon producing 27 every couple seconds, reasonable. But if we were to expand it out to the classic like 5 or 6 for a bullet heaven, we're still getting at least into this 3 to the 4th territory as far as expectations. 3 to the 5th, still reasonable. Let's increase the complexity a little bit. And zigzag. So this is very reasonable, and we get a really high frames per second for it. This is about where we want to live. Am I married to doing the floor tiles as a shader? No, and I'm rapidly approaching the it's more trouble than it's worth stage. But yeah, for reference, this is the weapon building system. One of the games, until I played it absolutely to death and don't want to play it anymore. Because we played it to death, we modded it, we played it to death. Like, we wrote a mod for it, is Noida. But one thing I still love about Noida is the sequential wand crafting system. So this is upon emitting the projectile, split into 3, then each of those projectiles splits into 3, and again, and so on. So we've got 81 projectiles. When they're moving, they move in a wave pattern. Along that wave pattern, they move in an outward spiral. And upon that outward spiral, they move in a contracting spiral. So they kind of loop-de-loop in place along the path of that spiral. And the default behavior of the yarn ball is emit in a random direction. So these happen first and kind of never again. But these 3 plus the random are happening each frame in order. I can even fiddle with this a little bit by doing this. The mice are placeholder entities. They will not exist in the final game. Well, the mice will, but the thing that they represent currently will not. This is wait for 3 seconds. So you'll watch the yarn balls will emit. 3 seconds later, they split into 9. Looks like 5. Trust me, it's 9. Then 3 seconds later, those split into 9 and they start moving. Welcome back, 10. So we can get some real complex logic. The core element of the game is going to be that the weapon itself doesn't upgrade. It's not like you get a level 2 yarn ball. It's that I get a power-up that I add to the yarn ball's weapon slots that change its behavior, increasing. They will always simultaneously give you a behavioral pattern like this. They move differently, they multiply, or something like that. Oh, here, let's zoom back in. This is a catbot. Character origin and lore is tied into a lot of the stuff that you'll be seeing in this game. Again, a lot of this goes back to the Noita mod. And the catbots were a major thing. The community Noita mod often devolved into weapons that could remove entire map chunks, and people in chat trying to hit me with orbital lasers over and over and over. There was an item in Noita that was essentially a green rock that if you kicked it, it would cause a kind of beam from the heavens to shear the map in half. Imagine that, but sometimes big enough to cover 2/3 of the screen, or narrower but happening every couple of seconds for upwards of 10 seconds. That was the boop. But we would have things like that. The goal of the game, once we started modding it, was kind of New Game Plus on speed, but automatic. As soon as you beat Colmy and went through the portal, it would immediately cycle you into New Game Plus with what you had. And the goal was to see not only how far we could get, how many New Game Pluses we could get as we proceeded, but additionally how big a number we could create with damage. We had the joke that was hitting seconds per frame was that you were doing it right. Hitting minutes per frame means you had achieved victory. We had a win against a high-ranked Colmy at one point, where the thing that killed him, the damage number that killed him, was over 1 quintillion. And each frame was often taking 1 to 5 minutes to play out during that damage blast. we added a lot of optimization to things like explosions to try to make it so that we could get those big numbers regularly. But that's the spirit that we're trying to create here, is that I want the weaponry to be able to go bonkers. That the win condition is not just I stand still and the sheer bulk of the default upgrades of the weapons does it. It's that I've got a combination that is devastating. And that's why we want this to be able to go out of control. I want to be able to have a ridiculous number of them. And this should hit that, by the way. 24,000 is the entity cap. It kind of gets wonky at that point. Entities cease to be produced if it hits 24,000. But this is about 24,000 moving, colliding entities, and we're still operating above 1 frame per second. Should you ever actually reach this case, if I build out the random gen, no, this should be incredibly unlikely. But with 6 weapons at once and some random generation, it's possible that you would hit several thousand things active on the screen at once. And that's not including the monsters coming at you, not including any extra behaviors like explode on impact, all of that. So we'll see how it ultimately plays out. This is all in theory. I mean, it's kind of a pet project at this point. Another fun thing is the order does matter on these projectiles. See, it's speeding back up as this number falls. Let's let it fully die out. There we go. So a wave pattern, then a spiral out, then a spiral in is different than a spiral out, then a wave pattern, then a spiral in. You can see the change starting to happen here. Just like if I delay the split, by doing this, this spiral becomes part of the default behavior of the yarn ball. It is, this portion to the left is unaffected by any changes to behavior based on stuff after the mouse. So now it's spiraling out on that random direction, but after some time they split, and the split direction is influenced by the spiral at that point. So the split gets, it's weirder, let's say. We can see some of that play out a little bit more if we have, let's reduce the number of things so it's more visible. We are going to have, there are 2 different types of wave motion. One of them is mislabeled at the moment. We really won't see spiral in happen for very long. It'll only happen for 1 second. This is the 112th stream. Generally upwards of 3 hours. I do a lot of chatting like this, so we usually don't get the full 3 hours. I do work a little bit on it offline. Yeah, you can see straight line, and then they'll start to S-curve, and then right near the end of their lifespan, they spit into a spiral, but only the random direction persists. The S-curve stops happening once the spiral begins. This is what I call gates in it, and these are going to be driving logic behind things like it explodes on impact is instead of a 3-second gate, it will be a gate that says I hit something. And as soon as the I hit something message happens, all subsequent motion will follow these new rules. There's more footwork that happens in the background here. But we've been working on it for a bit. I would say as far as like, if you viewed it as work days, more than a month. We're not going for game jam. We're going for the thing I want. Not necessarily perfectly the thing I want, but the thing I envision. So one of the challenges we're facing right now is that all of the visuals are scaled by 6 so that we can get them on the screen. I don't think we can keep using 6, but we're using 6 because we want it to be multiplied out in powers of 2, so we don't get like half pixels being rendered by the graphics card. That gets wonky. But 6 makes math weird. But we're kind of stuck with it. This is another reason I don't want to use the Godot tiles, because if I use the Godot tiles, I need to use Godot scaling, and that makes spatial math that much weirder. We could, though. We could. What I think we're running into as rounding errors here is that we're telling it that it should be this, like this pixel, but it actually should be the next pixel. Pixel in the tile map, I should say. So what our shader is doing right now is we know how big a tile is, how big the texture containing a tile is, how big the atlas of all textures is, what is the... This is effectively a bitmap where each color pixel represents the red channel on that color pixel currently represents which tile to use. This is how big the visible area is in pixels. If I... So right now we're using the UV value, the proportion of the size of, as far as the fragment is concerned, the proportion of the area of the texture we're writing to, and mapping that to the map texture. That should be fine unless we get rounding wonkiness here. So what if instead we compute that proportion ourselves? So we have a vector 2, and this is going to be the tile. And tile.x is equal to floor of x. This is very similar to what we're doing, but we're forcing it as much as we can to whole numbers. So we're getting a fraction of the visible area rounded down. And then we're converting that into a effectively a float percentage. And we're using that instead of the raw UV. I just want to see how it renders. I want to see how it renders, so let's jump over to the C code here. Move this -1, so it should be anchored at 0, 0. Let me actually run this. Oh, that's super wrong. That is super wrong. Oh, man. I thought I was onto something. Oh. Let's at least give it a fair go. Okay, well, that's closer. It's still way too small. Scaling doesn't seem to line up how I would expect it to. That's about right. About... yeah. It's about right. Not sure I'm lining up the catbot on the lines there properly, but... so let's revert that. These were all failed experiments here. Except for scaling factor. Let's keep that in there. We'll leave that. So way smaller than it should be. And just the tile size isn't right. So part of it is that we're not making this correctly here. So we're making it bigger in block pixel size. So we're making it 6 times bigger there. Forcing it to be the right size. Not using visible area size in our shader. And we have visible area size. Doesn't really change anything. I'm trying to do as much of it as I can inside of the C# code so that we can keep everything zippy. I also we have this view hiding data. So all of the objects in the game I've set up so I can define them in JSON. The goal of this is going to be to make it so that you can make your own like levels and objects and whatnot. And part of making a level is defining what the tiles are, what the textures the tiles use. And it'd be great if I could do that. So I don't think I'm scaling space anywhere. I think I was scaling space anywhere. Did I do something with the camera? No, the camera doesn't have a scaling factor on it. Not yet, Lunar. Though I do recall there is a NIS game, the folks that made like Disgaea and whatnot, called Rhapsody, a musical adventure, and I think there's a sequel as well. It's a JRPG. It uses a kind of awkward battle system where it's kind of a tactical grid. Yeah, not super fond of that, but the hilarious part of it is all of the major scenes are musicals. There's a lot of singing. This should be correct. This is necessary because I'm getting a proportional value here. But I think it's the sizing of the thing. This is the position in the visible area. But the fact that we're stomping that down to an integer should still be fine. So the size of the floor area is not coming through correctly. We're going to leave that alone. We'll just run it on the C# side because I'm not going to be looking at it that intently. That's closer. It's not moving like it should. Could anchor center, but that won't really matter. Anchoring upper left makes it easier. This is just logic to create that checkerboard. Should per block should be 30. We should get 480 by 480 when we get to here. This that's not right. Should be 480. Then by 3 is 1440. Why is block pixel size? Oh, times scaling factor of 6. Yeah. And then our visible area its size value is now triple that. Then we go in and we create the visible map. Purely tiles per block. So this will make the map texture bigger by a factor of 6. Map texture doesn't need to be bigger. Let's get rid of that. Hey, where is it? Now we're going to get our camera. Nowhere. Ah, okay. That'll cause a problem here. This is still correct. This is us determining how big a visual block is. The visible area size is scaled up. And we're passing that into the shader. Thought I already did this check. Not visible at all. About the right size. Let's zoom back out. Let's edit the shader to have that. in there. The start screen is very interim code at the moment, so it's easy to accidentally exit it. So mount 10x. We're still getting a bit of ripple. All right, now let's try to offset it properly. Switch over to cat cam. We'll do an interim here. Now we need to reposition it. I think this will be enough. Okay. Now this should jump entirely to our left, but we can see it's not quite doing it. Maybe it is. We are still getting distortion. You can see a bit of it. That's what the black markers are for, is to call out where it's mismatched. Some of it could be optical illusion. But I can also see that there's some rippling in the texture as we move. Let's make that a little more finite then. Make this clearer if we... that. Removing the color from here should make it more apparent whether we've got optical illusion or not. Thought, which I will use in a moment. That. Now what we're going to do... Select, convert, copy, new layer, the lines layer, paste you there, there. That, I don't want to delete the layer. Select, verse. That. The lines, okay, they go away. We're using these bright, virulent colors because we want to make it really apparent. This now gives me the ability to line tool, get rid of you, this. Reducing the amount of visual clutter that we're creating with this. Our tile 1. Our tile 2. Out. It's an optical illusion. Got 90 tiles to cross before we get out of the color zone here. We should eventually snap into another one, but no, actually, I think I'm using an empty. Yeah, I'm using an empty for that. Okay. Ah. That worked better than anticipated. Okay. So then the next thing is setting up the wrapping texture and coming up with some differentiation for that. Little debugging thing I made. This is the visible map. You can't see it clearly, but there's actually 2 different shades, actually 3 different shades of black possible here. For this purpose, it is 2 different shades. Both of them are slightly more red than black. And then our texture atlas here. debugging. Okay, we've got our offset, we've got our movement. Didn't have to use scaling here, which is good. Now let's add in our world map the concept of a wrapping texture. Need a folder. JSON handling. Screens. I'm very pleased that wasn't a dead end. Okay, so the wrapping map texture is the one that will be on repeat once you are outside of the actual world map. With the idea that currently the entire map block, however many chunks are in it, is set up all at once. So, for again, the example would be in base Vampire Survivors. The first level has fixed position items in each of the four corners. But if you go past that, it's just an infinite loop, but those items don't keep reappearing. They're only in the base position. Could I have special logic to insert fixed blocks? Yes. And we might revisit that for ease of creation, such that there would only ever be one. But I do kind of like the idea that there is a wrapping texture. Right now it is just a single chunk, you know? So this will load it, and currently this is going to be nothing. So we are going to programmatically edit that for testing purposes. So this is creating a 30 by 30 world map. So instead of this being I plus j mod 2, we are going to say mod 1. It will be 0 or 1. Should still load. I don't have JSON required in it. It's almost universally 1 here. Oh, plus 1. Right? Should be creating zeros or ones. Oh, this mod 2, 0 or 1. Okay. Going to then we're going to do this again. This whole thing again. Say world map. Wrapping map texture. Image texture dot create from image new map. All is greater. I want to swap it. This one. This one. File. Clearer. Okay, then when we are building the visible chunk here, okay, that's already not working there because I don't have anything up, upper left, and up. Red and then blue. have 0 and 1. Should be offset to force it. -1, -1. So we're out of bounds. Oh, no. Okay, I see where it's going wrong. Go over into Godot. We'll run it here. Over camera 1. Alright, let's just change the math a little bit. Blocks per map. A little further, I should encounter that. Encountered that by now. Back over to the Godot side. We switched. Godot lets me actually see the graphical objects as they exist, so I can go in and debug manually. Okay, that should have put one over here somewhere. Oh, wait. Well, I'm not going to be able to see it. Go into the logic for moving the player. Key behaviors, movement, move player. Times 52, that'd be hard to control. There it is. There's our wrapping map texture. Okay, then back. So we have 3 blocks per map. So if we bump this up to 90. Now we should see the blue right away. Yep. Okay, so now we're going to go over into the Godot side. Back and forth and back and forth, back and forth. Do be like that. So now we're on the Godot side. We're going to take our camera and we're going to go way out. You can see that only a 3x3 block of them is ever loaded. Should have kept the player speed going faster. That does need to be a... Speed of the projectile is... That's still something I haven't decided on. If I go down here... Now we're fully in the red. Now the next set of blocks to be loaded should be the blue ones. Those will be the wrapping blocks. So one possibility is instead of building this as the map directly, where each one of these squares is a pixel in a texture, I could build them in smaller and smaller units. I could build them as like individual 30x30s and stitch those into a grid and go from there. But ease of use with the map editing is going to be a thing. Because right now it's impractical to do it manually. But yeah. A little bit of progress. Alrighty. Honestly, didn't expect to get this far. Let's run that again. How's our frames per second looking with this going? Almost uninfluenced. One of the nice things is, as far as rendering goes, this object has like fixed rendering to it. We're going kind of up and down with this. Let's see how far we can get. Should still be able to hold round about 60 with this. Oh, we're going over 4,000. So I still need logic for creating them and editing them cleanly, tasks, but you can see here, the blue is the wrapping map texture. It is a blue checkerboard, and its spaces are offset by 1 compared to the red checkerboard. The red checkerboard is the main map. Currently, it's 30x30 per block. And the entire map is filled with the checkerboard. Okay. seem to be holding. Let's set these here. X, Y. Here. Demonstrate it a little bit better if I do this. Yeah, we've got block placement, we've got block rendering. Some of it was a lot of just staring at code until it worked. All right, we take that. We're going to run it in Godot so I can zoom out and show it fully. Oh, something's wrong with the wrapping texture side. I didn't do something right. That should be correct. Oh. We need more than this. It's to I map tiles. Verify that works. 30 blocks, 3 blocks in a map, 30 tiles per block, 3 blocks in a map. So map tiles is 90 by 90. Okay, and then we go over to the Godot side. Start it, we've got that. We're going to go into the game, into the camera, to the zoom level, 4x zoom out. Over 10x. So a 3x3. It'll take us a moment, but if I keep moving to the right here, keep moving to the right. Move back. It should snap pretty quick. Getting to the edge of the block so we can demonstrate here. Might be a flaw with upward motion. Upward motion isn't working. Downward motion works fine. Upward motion isn't detecting properly. This is us creating the world map. So we get map blocks, update. It wasn't updating the block is the problem. Let's make the player move extra fast for now, so we can test this. And blocks per second. Yeah, okay. I am reaching the edge of visible space before it loads more. Should not be. Right now, we're determining the player block as if it were the upper left corner. So I have to cross all the way above the upper border before it would update again. So this doesn't account well for upward motion. Especially in negative space. Because it's going to default downward. And then we're pushing it back upward with this. This needs to be here. There we go. Yum. Still takes 9 seconds to traverse the area there. That's not right. Alright, it looks like the lower chunk space isn't loaded. Down is fine until we're past this visible space. So I think the wrapping texture logic for exceeding the lower bounds is wrong. Or put another way, it's definitely wrong. This is less than 0, greater than or equal to blocks per map. Does this ever trigger? Yes, it does. There. Hey there, Displant. Welcome. Very nice. So the next thing is going to be, I think, how to edit these. I need a good way to edit this that is not reliant on me trying to edit the textures. I'm sorry, the textures that represent the maps. You can just barely see the red dot there that represents 0, 0. I am considering either a completely separate tool to start generating some of these files. I could look at Excel spreadsheets for some of it. I would need a good way to visualize within the spreadsheet, which is still possible. But yeah, we have the basics in place, even running around the map like this. We're still able to maintain a really large number of frames. It turns out it wasn't a rounding error. It was that I wasn't accounting for the scaling properly. And by wasn't accounting, I mean I wasn't making this, the visual rectangle that is being drawn here, big enough. Because essentially I was overthinking it. It's the shader writes to space. So when I'm looking at tiles, it doesn't matter how big this map gets. I don't need to change the calculations for which pixel I want to tell it to be based on the size of the background here. The shader works independent of that. If I stretch it huge, these tiles get bigger and bigger. The only thing that I need to account for is to stretch it bigger. So, like, I can... Hopefully I'm not going to sound silly, because this should work. Yeah, there you go. Doubled the dimensions. No change to the shader at all. Now, the other aspect that I thought was a rounding error was an optical illusion caused by having these really bright colors adjacent to each other and adjacent to the black. It made the ones that were in the red look like the black was bulging, whereas the blue one would look contracted around it. But by pulling the colors away from the edges of the tile, it removed that. So yeah, we got a thing now. So again, next concept is going to be how to build this. How I'll make a bunch more testing tiles, and we need to come up with a way to create that level, to render that level out. In a maintainable fashion. I can probably do that with spreadsheet shenanigans. Be a bit wonky, but it's possible. If I were to go in and say this image is equal to this number, I could just have an option to go in there. It'd still be slow because I'm not painting it. I am setting numbers, you know? So that's where having debugging tools, whether they are hidden in the game or they are exterior to it as a separate program that is just like drawing. But there is a bit of an advantage in doing it inside of Godot, and that's that I can use Godot's tile map, which is a painting interface. You just smear the tiles around. It'll be interesting to see. That might still be a good way to do it, because then I can come up with... I can use Godot to create the tile map. Like the actual texture atlas kind of thing. And generate it that way. So I could have more robust things, like easier borders between, say, like a dirt road and grass would be a hassle to do this way, because I would be manually setting each texture. But if within a texture, if I have all those textures laid out, if I have individual files for all of them, I could still have that same effect. The classic, 3x3, 3x1, 1x3, 1x1 kind of pattern for painting sprite tiles. But yeah, I think we're going to call it a bit early today. I want to take the win. I want to take the win. So we identified remaining issues in the placement, sizing, and rendering of our background tiles, which means they are working now. We can display a map. There's still some edge case stuff I want to put in there. Like, I want to move scaling factor into a true globals. I may actually make that part of the resource file, such that everything can look and say, what's the scaling factor? That will make it easier if I start changing the master scaling. Like, if I want all of the sprites to be bigger and the map tiles to be bigger proportionally, I would want to put something there. It would also remove... If I have one spot for it, I don't need to worry if I want to change effectively the zoom level. If I were to change to 32 by 32 sprites, I would change the scaling factor to 3, zoom out a little bit effectively. It would technically make the sprites a little less smooth when they move, but 3 pixels to actual sprite pixel is still, I think, pretty smooth. But it would mean that there's one spot that I place it, you know? But this is where the math lives for now. The other place that it lives is out in the renderer, and then there is an assumed location that it lives inside of a lot of movement code. So having something that says this is how... Having a location that defines that kind of constant, like how big is the screen in proportion to the screen, in like pixel assumptions, how fast does something move? Like 96 right now is at scaling factor 6 with 16 by 16 sprites. 96 is about one square, one 16 by 16 tile per second. If I set that to be the speed. That concept of what is the origin of the speed is something useful to have algorithmically somewhere. You know, what is my speed of 1? What is my speed unit? But that's later. We need to get the map editing first. So I think what I'm going to do is build a set of screens in Godot that we can make available in like developer mode. That is to go in and create files. Have a file browser to be able to open them, edit them, save them, and create new ones. The map being the one I'm most interested in for now. Right, Tess. It's if I can figure out what unit speed is, what is one speed unit, then I can have a trait in entities that is their speed. And I can supply that accordingly. That way, we can control how quickly things move. We can also go in and start doing things like speed of projectiles is not additive with movement. I mean, the speed units could still be, like, exposed to the player very clean or very opaque. In code, it could still end up being yarns per parliament bill. But there would still be that sort of logic for identifying that. Like, what constitutes all of these values and what is the algorithm for mushing them together into one speed? But good times, good times. We got that basic stuff in there. I think we've got our next goal, and that's going to be build tools, development tools for creating those JSON files. there's going to be some wiggle when it comes to the maps. I need to come up with a wrapper for the texture objects that is potentially is just an extension of the objects that I'm dealing with. Like I deal with them as image textures inside of it. So if I were to deal with them as I deal with them inside of the code as texture 2Ds. So if I were to extend a texture 2D and just say, this is your file, or this is the name of it, when it spits it back out, that might work. Now, hopefully the way I'm doing it will work, but effectively deserialize them into an object, manipulate that object in a GUI, and then be able to save them back out either as a new file or to overwrite the existing file. That way I can build creatures more cleanly, especially given that by knowing all the data loaded in from an entity, I can get things like, what is the sprite? I could have the sprite there on screen and show it. This is the texture file, kind of thing. I could load them in and have that be something that saves off. This is the entity as it is. So we've got some layers to that. We've got some stuff that we can do. I think that's where we are, is starting to get some dev tools set up. But yeah, I hope everybody had a good time watching with us tonight. If you like what you saw and would like to see more, remember to like, follow, subscribe, comment, all of those good buttons. They help the channel grow. With all that said, though, I hope the rest of your day is good, and I'll see you next time, hopefully tomorrow.